Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all fine. Lecture for grade 10, boys and girls, both wings, subject chemistry. Chapter number 11, that is organic chemistry. And today we will do the exercise. This is my 15th lecture, and here is Mrs. Saira Jamal. Dear students, in this lecture we will do the exercise of chapter number 11. The MCQs we have done in the previous lecture. Today we will do the short question answers. The first question is, what is catenation? Catenation is the self-linking ability of carbon to form long chain and rings is called catenation. Carbon atoms can link together through covalent bonds. You can see in this case, this is a chain of carbon atoms and it is called catenation, chain of carbon atoms. So we can also call it N-butane. N-butane means straight chain butane. And to form rings, another property of carbon is to form ring. You can see this is hexane and it is also called cyclohexane because it is in the ring form. So the ability of carbon to form long chains and ring is called catenation. Due to this property of carbon, millions of organic compounds are present in our surrounding. So carbon atoms can link through covalent bond. Which type of bond is present between carbon-carbon? Carbon-carbon is linked to each other through covalent bond. Question number 2 is define isomerism. Isomerism is another reason for the abundance of organic compounds in our surrounding, and this phenomena is called isomerism. The compounds that have same molecular formula but different arrangement of atoms in their molecules are called isomers, and the phenomena is called isomerism. For example, pentane has three isomers. The first isomer, where all the carbon atoms are in straight chain, is called N-pentane. The second one, when one of the carbon atom or methyl group is in branch, is called isopentane. And the third case is when two methyl groups are present as a branch on the main chain is called mu pentane. This means that three compounds have same molecular formula, but the number of carbon atoms in the organic compound increases, the number of possible isomers also increases. There are three isomers of pentane. Next question is about alkyl radical. Give three examples of alkyl group. So what is alkyl group? An alkyl radical is a group of atoms obtained by removing one hydrogen atom from an alkane. So we will get alkyl radicals. Alkyl radicals are represented by the symbol R. General formula for alkyl radical is CnH2n plus 2. For alkane is CnH2n plus 2. But for alkyl group is as it is one hydrogen less than alkane. So instead of plus 2, there will be plus 1 hydrogen atoms. Alkyl radicals are named by substituting the suffix YL for N. N of the alkane is replaced by YL. So from alkane, alkyl, in the name of alkane from which they are derived. For example, if we have methane, so by removing one of the hydrogen from methane, you will get methyl. From ethane, ethyl. From propane, propyl. There are two types of isomers of propane, N-propyl and isopropyl. Propane has two isomers when a hydrogen is removed from the first or last carbon atom, then it is called N-propyl. But if hydrogen will be removed from the central carbon atom, so this type of isomer is called isopropyl. Question number 4, define a functional group. So functional group is an atom or group of atoms or presence of double or triple bond which determines the characteristic properties of an organic compound is termed as the functional group. Functional group are not only the extra atoms or group of atoms which are attached with the hydrocarbon, but the double and triple bonds are also a type of functional group which can give some specific properties to an organic compound. The remaining part of the molecule mainly determine the physical properties such as melting point, boiling point, density, etc. Greater the number of carbon chain, definitely higher will be the melting point and boiling point and density of that organic compound. And like for example, OH group is the functional group of alcohol, which gives characteristic properties of alcohol, and the characteristic properties of carboxylic acids are due to the presence of functional group like COOH, which is also called carboxyl group in them. Therefore, functional group of carboxylic acid is COOH group. This is called functional group of carboxylic acid. Question number 5. What is the difference between an alkane and alkyl radical? So alkanes, hydrocarbons whose carbon-carbon bonds are all single, are called saturated hydrocarbons, and saturated hydrocarbons are also called alkanes. In alkanes, each carbon atom is attached with 4 other atoms. General formula of alkane is CnH2n plus 2. One more thing, alkanes are also called paraffin. Para means little and affine means affinity for other compounds. As the valency of carbon is completely satisfied, so it has less affinity for other atoms to form a bond with them. Alkyl radical, I told you about that when one hydrogen is removed from an alkane, it is called alkyl group. It is represented by the symbol R. General formula is CnH2n plus 1. And the N of alkane is replaced by the YL of the alkyl group. So example, I also told you methane, from methane to methyl, ethane to ethyl, propane to n-propyl, and isopropyl are the examples. Coming toward the extended question answers, the first question, which is question number 3, what do you mean by destructive distillation? Destructive distillation is a chemical process involving decomposition of a solid by heating it in a closed container. Closed container means in the absence of oxygen. Absence of oxygen, the solid is heated at a high temperature. What will happen? That solid will decompose or breaks up into its components, and the components you will collect it in separate container, closed container, and collecting the resulting volatile constituents. Now, the destructive distillation involves the separation of components through decomposition of a solid, as we discussed in case of the destructive distillation of coal, which gave us 3 products like coal gas, coal tar, and coke. So the apparatus includes 2 test tubes connected to each other through side tubes, one containing coal and other containing water. So mainly used for coal distillation, mainly destructive distillation we use for coal distillation. You can see we have 2 test tubes, one has coal in it, powder coal, and the other has water in it. So by heating this, and you can see that it is, we kept it airtight by putting a cork in it so that air cannot enter inside the test tube. So this is in the absence of air. By heating this coal, the coal will decompose into coal gas, coal tar, and the coke will left inside this test tube. Coal gas and coal tar will pass through this bend tube, and then you will collect it in the test tube which contain water in it. Next question is identify the following compounds on the basis of functional groups they contain and encircle the functional group. So you can see that in this case we have carbon-carbon double bond. So this is an alkene. Alkene has carbon-carbon double bond. And in this case carbon-carbon triple bond. And which type of alkene is this? As it is 3 carbon containing alkene. So we can name it as a propene because it has 3 carbon atoms. So prop and N of alkane is replaced by ene. The name of this compound is propene. And this compound contains carbon-carbon triple bond, and there are 3 carbon atoms. So we can name this compound as propyne. Again, N of alkane is replaced by Y and E. So propyne. This one is propene, and the second one is propyne. The third case, there are again 3 carbon atoms, but a carboxyl functional group is present over there. And when carboxyl functional group is present there, then we will call it propanoic acid. Propanoic acid. And in this case, again, COOH, this is the condensed form of the carboxyl group, and this is the structural form of the carboxyl group. So this is two carbon atoms are present. So for 2 carbon atoms, we will use the term ethanoic acid, ethanoic. This one was propanoic because 3 carbon atoms were present, and this one is ethanoic because 2 carbon atoms are present in this acidic group or in this functional group, which is carboxyl group. The fifth one is you can see carbonyl carbon atom C double bond O is called carbonyl group. Carbonyl carbon atom is present in the middle and the 2 alkyl groups are present at the side. So this type of functional group is called ketone. And for ketone, I told you we will use the term ONE1. Like there are 3 carbon atoms, we will use the term propanone. Propanone is the name of this compound. In this case, CH3, C double bond O, OCH3. C double bond O, OCH3 is ester linkage. So this one is an ester group, and the name of this compound is 1, 2, 3 carbon atoms are there. So we can call it methyl ethanoate. Methyl group, this we will call methyl, and the rest of the group we will name it as ethanoate or methyl acetate also. The last one, carbonyl group containing at one side methyl or alkyl group and at one side hydrogen is present. So this type of functional group is for aldehydes. You can see carbonyl group containing compound along with OH is there. So this is carboxylic acid functional group, not carbonyl, carboxyl group. So you can say this is X carboxyl group or carboxylic group. And in this case, carbonyl group is present in the center with 2R, so ketone. And in this case, carboxyl, not carboxyl group, acetate group or ester linkage is present. And in this case, again carbonyl group, but this one is aldehyde. Upper one is ketone and the down one is aldehyde. Because in this case, 2 R groups are present. And in this case, 1 R and 1 hydrogen is present. If 1 R and 1 hydrogen is present along with the carbonyl group, then that type of compound is called aldehyde. And if both are alkyl groups, then that type of compound is called ketones. Question number 7, what is the name of alkane having 6 carbon atoms in the chain? Alkane having 7 carbon atoms in the chain is called, for 7 we use hept, and for alkane we use N. So heptane is the name of that compound which contains 7 carbon atoms. Question number 8 is what is the name of the alkyl group obtained by removing an and hydrogen atom from propane and from ethane? So we discussed it before that one of the hydrogen atom, if it is removed from propane, then the alkyl group which we will get is propyl. But those propyl group will be isopropyl or N-propyl depending upon the hydrogen which is removed. And from ethane, we will get only one isomer, that is ethyl. Question number 9, give the structural formula of 2 simple alkanes and 1 alkyne. Structural formula of 2 simple alkanes. You can see we have methane, carbon having 4 hydrogen atoms attached through single covalent bond. Ethane, 2 carbon atoms where 6 hydrogen atoms are attached through single bond, and this one is propane. Prop means 3 carbon atoms. 3 carbon atoms are attached with like 3, 3, 6, 7, 8, 8 hydrogen atoms. So this one is propane. So all these 3 are the structural formulas of simple alkanes, and this one is, and 1 alkyne is, you can see carbon carbon triple bond is for alkyne. So So this will be propine, and also ethyne. For 2 carbon atoms ethyne, and for 3 carbon atom you can use the term propine. Propine, YNE for triple bond, and YNE for triple bond. So propine and ethyne. And if all the bonds are single, then you just use N. Propane, ethane, methane. And if it is double bond, then we use the term ene, ethene, propene, butene. But in this case, we have only single and triple covalent bonds. Question number 10, what is meant by the functional group? So I told you before that functional group may be an atom or group of atoms that give a family of organic compound. Its characteristic chemical and physical properties is called a functional group. So I told you before that functional group may be an atom or group of atoms or double bond or triple bonds. Now you can see in this table, the first name of class is alkane. Alkane has no functional group, but it has general formula RH, and all the bonds are single. Carbon-carbon bonds are single. In case of alkene, C double bond C is the functional group, and the rest of the bonds are completed by alkyl groups. And in alkyne, there are carbon-carbon triple bond, and the valency is satisfied. 3 bonds are already here, and the 4 bond carbon make with R. So R may be hydrogen or any alkyl group. Alcohol functional group is OH. So alkyl group CH3OH, and or C instead of CH3, which is methyl group, and which is an alkyl group, we can also write ROH. Then ether, if oxygen is present in the middle or in the middle of 2 methyl group, it is called ether, or we can also call it dimethyl ether. And as both are CH3 group, so CH3 groups are called alkyl group. So we can put ROR. R bar means that this alkyl group may be same or they may be different. Then carbonyl group with at one side hydrogen and at other side any hydrogen or alkyl group is aldehydic functional group, and we will use R instead of CH3 or 2 carbon chain or 2 carbon containing chain or whatever, but we will use the term R for alkyl group. Same is the case for ketone, carbonyl group in the middle and 2 alkyl groups will be present at the side. You can see 2 alkyl groups at the side. Amine having functional group like C, methyl, and one of the bond is with nitrogen, and nitrogen will make its 2 bonds because you know that nitrogen is present in group number 5, and it will make the triple bond. So you can see nitrogen is making 1 bond with carbon and 2 bonds with 2 hydrogen atoms. So R and HR. You can see in this case only 1 hydrogen is present, and the R may be same or it may vary in case. So these are the amines. Carboxylic group is C double bond O, OH, and again we will write R for alkyl group. For ester, C double bond O, O, C. So this is, or CH3, this is ester, and R, R, C double bond O, O, R is the functional group. Question number 11 is that we have to identify the type of following compounds as an alcohol, as an aldehyde, or ketone. We have to identify the functional group in these compounds. So the first one is, you can see the formula HCHO. You can see CHO means carbon is making a double bond with oxygen, and 2 hydrogen are present at the 2 sides. So when carbonyl carbon atom has at one side and at both sides hydrogen, and it makes double bond with oxygen, so definitely it is an aldehyde, and the name of this aldehyde is formaldehyde. So formaldehyde, which is used to manufacture polymer such as urotropine, which is used to treat urinary tract infection, which are also called UTI. So to cure UTI, this formaldehyde is used, or it is used for all the other kidney problems or urinary tract problems. B part you can see is CH3COOH, not 3, COOH. Again, in this case, carbon is making double bond with oxygen, and OH or hydroxyl group is present at the other side. And this is the formula of, you can say, acetic acid or acetone actually, because this is CH3 C double one O OH. This must be CH3. Okay, this is not O. This is CH3 C double one O CH3. Then CO, the carbonyl group, will be present in the center, and two CH3 or R groups are present at the two sides. So this one is called ketone, or the proper name, or or the specific name for this organic compound is acetone. And acetone, you know, is used in nail polish remover. Next one you can see is two carbon containing compound and having OH attached with it. So it means that this is an alcohol, and it is used in the preparation of many organic substances such as plastics, cosmetics, tinctures, etc. All these compounds may be formed from alcohol. You know, alcohol is antiseptic, and even alcohol is used as a sanitizer, like the specific percentage of this ethanol, which we dissolve in water to make its dilute solution, and then we can use it as a sanitizer. So solution for this question number 11 is, the first one is aldehyde, because CHO group is aldehydic functional group, and it is attached with the carbon atom. And this one is ketone, because CO group is called carbonyl group. It is attached with two methyl groups in the center. And the third one is alcohol, because OH group is attached to an alkyl group. And we know that when OH group is attached to an alkyl group, then that type of compound is called an alcohol. So you can see here the functional groups of some compound, and in case of alkane, I told you that all the carbon-carbon bonds will be single, and in case of alkene, and one more important thing is that you have to complete the valency of each carbon atom as 4. So in this case, R is the methyl group, so CH3, three hydrogen atoms are already present, and one hydrogen atom is this. So there are total 4 hydrogen atoms. So this one is actually the formula of methyl group with hydrogen, so methane. And methane is an alkane, because all the carbon-carbon bonds are single. But in case of alkene, carbon-carbon bonds are double, so 2 bonds are present in the middle, and I told you each carbon atom will make 4 bonds. 2 bonds are present in the middle, and the rest of 2 bonds carbon will make with hydrogen atoms or with alkyl groups, whatever is available in the reaction. So in this case, you can see it will make the other 2 bonds with 2 alkyl groups for 1 carbon atom, or for each carbon atom. Total 4 alkyl groups will attach with the alkene. That's why the formula of alkene is, we can say, is C2H4, because 4 hydrogen atoms are attached. In case of alkyne, 3 bonds or triple bonds are between the 2 carbon atoms, and the fourth bond it will make with an alkyl group, or it may make that with hydrogen atoms. So if we can take the example of ethine, ethine formula is C2H2, which has 2 hydrogen atoms attached with it at the two sides. But instead of hydrogen, there must be alkyl group as well, and those alkyl groups may be same or they may be different. It is not compulsory that these bonds must always be same. For alcohol, I told you OH group with alkyl group. With alkyl group CH3, I told you you can write CH3 or you can write R. R is also alkyl group. So alkyl group or CH3 group, they are same. So in this case, there are two CH3 groups at the two sides of oxygen. So this is called ether or ethereal linkage. And this C double bond O is called carbonyl group. And if at one side of the carbonyl group, hydrogen is attached, and at the other side, if it is hydrogen or any alkyl group, then this compound is called aldehyde. And if at the carbonyl carbon atom at both sides, hydrogens are attached or like the alkyl groups are attached, so that type of compound is called ketone. And in amine, I told you with the methyl group, NH2 group is attached. If NH2 group is attached with the carbon atom, it is called amine. But if NH2 group is attached with the carbonyl group, like in this case with carbonyl group, then that type of compound will call amide. This is the main difference between amine and amide. In amine, nitrogen is attached with the alkyl group. But in amide, nitrogen or NH2 group is attached with the carbonyl carbon atom or C double bonded O carbon atom. Then carboxylic acid is C double one O OH. We can also write it in the form of COOH, which is the condensed form, and this is the structural form. And instead of this part, which is vacant, there must be any R or there may be any hydrogen over there. Ester linkage is C double one O CH3 or CH or any alkyl group depending upon the condition, then we will get this ester linkage. Phenol is also one of the functional group, and I told you before in my previous lecture that phenol, we can also consider phenol as a functional group where at the sixth chain ring or the six carbon chain, the alternate double and single bonds are present, but one of the hydrogen is replaced by the hydroxyl group. So this is called hydroxy benzene, or also a common name is phenol. So organic compounds have different names. They have common names as well as IUPAC names, and IUPAC names are mostly used all over the world because it is same all over the world and it helps us to understand about the organic compounds. So now you can easily identify if you will understand the table where different functional groups are given. So you can easily identify the functional group in any of the compound. That will be easy for you. So dear students, hope you understand this lecture. Inshallah, the remaining questions like that is a think tank questions are left. Inshallah, we will do think tank in next lecture, and also we will start the next chapter. So till then, take care. Allah Hafiz.